So today we'll be solving some classic differentiation problem that are like tricky in the exam because they require combining multiple rules or using specific algebraic techniques that students often forget under pressure. So if we think and look at this very first problem, let's solve this one. First of all, we will be taking the natural log for this problem of both sides. So we will write like this. Then the next is use log properties to bring the exponent down. Then we will be doing differentiate implicitly. The left side becomes and the right side requires the product rule. So it will be like after that, if we like isolate that dy by dx multiplied by y, we will get and after that we'll be like substitute back the original y. So the very first problem, this is the answer. Okay, so we will be heading towards our next problem. The next problem is this. So let's start to solve this. This will be like the nested chain rule, or we can say the Russian doll. This is a triple layer function. So students often differentiate the square root and the cosine, but forget to differentiate the innermost x square. So first, we'll be rewriting the radical as a power. So like this. The next one is layer 1 and layer 2. Layer 1 will be outer power and layer 2 will be the cosine. So if we say like layer 1, we'll be writing like this. And layer 2 so we can also write this. And there will be another layer that would be the angle, and the derivative of the x square is obviously like the 2x. And if we all multiply layers together, and then we will be like simplifying the half and the 2 cancel out, so we can write so this is the answer. We'll be moving forward the next problem, and which is like the implicit differentiation with product rule. And here what students struggle, like they forget that y is a function of x. Every time you differentiate a y term, you must attach a dy by dx, the chain rule. So if we just move to the solution part, differentiate the first time like this using the product rule, okay? And then we have to differentiate the second term, and we have that constant 5. So this would be and this one, and this one is 0. And if we assemble the equation, we will get then if we group the terms, then it would be so ultimately the result is this. Next and the last question we will be solving today, the quotient rule with a twist. So let's see the math problem here. And the students here struggle is like combining the quotient rule with the chain rule often leads to sign errors or forgetting the denominator squared. So if we go for the step-by-step quotient rule, we will be like, the rule is like low d high minus high d low and low squared. So to find the parts, we will be like the low is it's like 2e2x. Please don't forget the 2 from the chain rule. And then the I is e to the power x, and then t low is 1. And if we plug into the formula, it will be like then we have to be like the factor and simplicity, put all that e to the power 2x from the top. We'll be writing like this. And this is how we got our answer. If we look at this, like if I want to tell that how this differentiation maths connecting with machine learning also, like even though these look like a pure math puzzles, like they are the engine behind machine learning. Like in AI, we use these exact rules, especially the chain rule and the implicit differentiation, to calculate how much a model should change its internal settings to fix an error. It's like when you are solving for dy by dx in your exam, you're actually doing the same logic that helps a self-driving car learn how to steer. So this is all about this video. Hope you guys enjoyed it. So yeah, see you next video. Bye.